everyone. I am Danica Padilla and I am here to discuss to you the activity on Chapter 4, Basic Estimation Techniques. To begin with, I am going to read to you the problem we have. The following matrix shows the mean net profit for MNPM and mean corporate social responsibility or MCSR of 74 publicly listed companies or PLCs, taken as sample from a total of 250 PLCs. The MNPM is the PLC's average net profit margin from 2003 to 2010. The MCSR is the PLC's average expenses devoted to socially responsible business activities. Data were taken from the income statement component of the PLC's financial statements posted online through their respective websites. The MNPM was calculated by adding the net profit margin of the PLCs from 2004 to 2010 divided by 7. The MCSR was expressed as ratio of expenses devoted to socially responsible business activities to the PLC's total expenses from 2004 to 2010. To understand this case problem, we have to follow our task or our requirements here as our guide to solve it. It's our first task. It is to determine the relationship, if any, between profitability of the PLCs as indicated by MNPM and socially responsible business practices of PLCs as indicated by MCSR. So we have here our requirements as our team to follow the steps in hypothesis testing. The first one is to state the null hypothesis. The null hypothesis would be there is no significant connection between PLC's profitability as measured by MNPM and socially responsible practices of PLCs as measured by MCSR. The second requirement is to calculate the coefficient correlation. For us to be able to get that, we have to list first the 74 publicly listed companies. Then we will get the MNPM and MCSR data. Then after that, we will get the data we input from DBO to TOL company from the MNPM and MCSR. So our correlation coefficient would be 0.1694. Our third requirement is to interpret the coefficient of correlation. There is a weak positive relation between PLCs as indicated by MNPM and socially responsible practices of PLCs as indicated by MCSR. Fourth requirement is the test for the significance and non-significance of the coefficient correlation that we will be using a t-statistics. You can see in our screen, we have our t-statistics formula. It is t equals r square root of n minus 2 over 1 minus r squared. Applying the t-statistics formula, we have t equals 0.16942, which is our coefficient correlation. Square root of 74 minus 2 over 1 minus 0.16942 squared. So 74 here is our publicly listed companies. Minus 2 is given. Then over 1, this is given also, minus 0.16942 squared. So t equals 0.16942. We copy it from the first one. Square root of 72 over 0.97129687. So the 72 here is from the 74 minus 2. So we get 72. Then over 0.9712968856. That was from 1 minus 0.16942 squared. So t equals 0.16942. We'll be multiplying it from 8.60974436. So we get our t-statistics of 1.45866,306. If requirement is to compute the computed statistics. So this is my graph. I will be just presenting it to you. So just remember that the edges of this loop are the colored one, which is yellow there or orange. That was the rejection region. Here is my summary output. We have also the regression statistics and even the ADOBA. So this will be our guide to compare the computed statistics. There is no significance because the significance F and P value for R is 0. 149006674, which is greater than the value of alpha of 0.05. Therefore, the null hypothesis has a strong evidence that we cannot reject. The sixth requirement is to apply the decision rule. In applying the decision rule in this case, we would accept it. The requirement is to justify your decision. So my decision is to accept it because the result of critical values, which is higher than the tabular value of statistics, that makes sense for me to make a decision accept it. In letter B is to graph the matrix using the scattered diagram. Here is my scattered diagram. As you observe, I just input those data and you can see even the MMPM and MCSR are there, and even those small red boxes represents the series 1, or there is a weak positive relation. C is simple regression model with the formula of y equals a plus bx. So there is our slope, which is 0.0952. The result is 12.912. So the regression model would be y equals 12.912 plus 0.0952. Take note that our slope is from our coefficients, the x variable 1, which is 0.0952. B is to draw the trend line in the scatter diagram. As you can see, I just input the data and